Hello, Industrial Advisory Board. My name is Brent Astrosky, and this is the second part to my senior project. Just for a refresher, my senior project is manpower forecasting. So as for the agenda, I'll briefly go back and give you guys some background, provide you a statement of work, the proposed method I'm using, and all that's reviewed from last quarter. And for this quarter, I'll tell you about the selection of variables I use for my method, the analysis of my method, and essentially what's next and what to do with what I have done for the senior project. So as a reminder for the background information, I worked for a company over the summer over in China where they worked in the field of the construction of ships. And mainly what they have is surveyors at shipyards that go about and check quality specifications and the actual construction of these ships and make sure they're being done to industry standards and safety requirements. So in general, the purpose of this senior project, which was a continuation from my summer internship, is to rightfully forecast, to the best of my ability, the manpower hours per month of all of China. But recently, since fall quarter, the scope has changed, as it was now directed just to one single district in just China, where now there are several districts there too. And as it pertains to industrial engineering, it's a forecasting method. So it's a little bit of 410. It involves statistics, which is IME 326, and I had to use some of my overall process knowledge to understand the variables being used as well. So once again, at the end of last quarter, I mentioned to you guys that I'll be using a multiple regression analysis. The benefits of using this analysis is that I'm able to use both quantitative and qualitative variables part of the equation. The limitations, as you'll see further, is that there has to be general assumptions made and met in order to fully use this model. And once again, this is a heavy statistical approach. So I'll explain further through graphs and p-values of what has been done. So before actually going about and using the model, I had to select variables to input in the model. Now for regression, you have one dependent variable. In this case, it was the number of hours that are going to be forecasted. Now this dependent variable is based on a bunch of other predicted variables or independent variables. For these ones, these include month number of the project, so which month the project is currently in, the type of shipyard it is being constructed at, because there can be variability among shipyards, the vessel type, compared, let's say a bulk carrier compared to an oil carrier, the number of days in between milestones, and these milestones are set before the construction of these ships, and this is meant to use for seasonality changes. Then also the weights of the vessels, as well as the weights there's variabilities among the weights in the vessels as well. So using multiple regression, or otherwise known as stepwise regression, I was essentially able to come up with this equation as you see based on the variables I inputted. I used the statistical software Minitab to help me generate these coefficients and constants to predict the essential number of hours needed for manpower forecasting. Now what this uses is the stepwise uses significant p-values, especially at the 0.05 level, that determine if a independent variable is useful in predicting the dependent variable. So in the end, after running the regression, Minitab selected the dead weight total, which is a weight measurement, also GT, which is another weight measurement, a milestone known as finish keel to launch, which is part of the seasonality changes, actual month number, the start finish launching to delivery, which is a difference between two other milestone days, the vessel type of a barge, the vessel type of a bulk carrier, the vessel type of an oil carrier, and the vessel type of a liquid nitrogen gas carrier, also known as LNG carrier. And once again, all these predictors were significantly useful at the 0.05 significance level. So now once you have the model, you have to check out the assumptions, which is pretty key when using regression analysis. Now, there are three major assumptions in using stepwise regression. This includes the normality of the residuals, which means that the equation values minus the actual values are normally distributed. The homogeneity of the residuals, which means that essentially the variability among the predicted minus actual are relatively the same, and that the model is generally linear in whole. So now looking into these assumptions, right off the bat, I plotted the normality of the residuals. Now it appears that it might be semi-normal, but once running an Anderson-Darling test, it appeared that this assumption was violated and it did not pass. And looking at the other assumption, the equal variance of the residuals of this model, it was violated as well. As you can see, there's kind of a fanning pattern as the fitted values continue throughout, which is not good, and it violates equal variance of the residuals, or the homogeneity of these residuals. But there are ways to manipulate the assumptions and potentially get around them. The ways that you can do this is you can transform the dependent variables, meaning you can either square them, log them individually, take the square root, or you can transform the independent variables in itself too. And the same thing applies. Or you can do both at the same time as well. Also, you can remove extreme outliers as well to see if the normality assumption is met. So I did this, and the first thing I did was just to manipulate the independent variables. Now, after doing this, and getting the equation, and after plotting the residuals on a normality histogram, it semi-appeared that it was normal, but once again, going further and using a normality plot test, that assumption was violated. And looking at the equal variance of the residuals, that assumption was also violated. As you can see, there is still a fanning pattern. Now, another transformation I used was just the dependent variable, so the predicted variable of the hours, and using the same variables of the original regression. Now, as you can see, the normality of the residuals is not at all, as it actually is skewed right severely. So once again, this assumption is violated. But looking at the residuals of the homogeneity or equal variance, there seem to be a little better, as there isn't such a fanning pattern anymore. But still, since the normality assumption is violated, cannot use that model. So then I decided to transform both the independent and dependent variables. So after running the test of normality, that still was violated, but the equal variance assumption was essentially met, as there isn't really a fanning pattern. They're semi-equally relative to the zero line. But since that normality of the residuals is violated, I couldn't use the model, and therefore my method cannot be used right now. I also manipulated with the outliers, and that did not change much out of the data, and you don't want to start removing outliers, because that will now be more of a biased model too. So now the question is what to do next. After discussing with my advisor, Dr. Paragabavar, we decided that I need to consult with the statistics department of how to handle these violations. More directly, Dr. Varagar suggested it's going to be a non-parametric regression. But if that doesn't work out, I would have to potentially collect more data observations from the company. Like I said before, this is from only one district, so if I gather values from all other districts and maybe go back to my original scope of doing all of China, it might be actually able to get some normality data. As you know, as the number of observation increases, the more likely it will be normal. So in a sense, this will be done next week, as today I'm just meeting with the statistics department. So after that consultation, we'll see where it goes from there. So when I talk to you guys next week, I hopefully will have results. Thank you for my presentation, and talk to you soon.